Okay, guys, on to pendula. Plural for pendulum, for those of you who are wondering if I have like some kind of a stutter or something. So when I pull that pendulum back, we talked last Thursday, seems like ages ago. We talked last Thursday about the period of a pendulum. We tested all the different variables and created an equation that looked very similar to mass on a spring. 2 pi times the square root of L over G. Mass doesn't matter, angle doesn't matter. But all of the characteristics that we solved for, that we just derived, are also characteristics that we can figure out for a pendulum. So what's the acceleration at the peak right here when it's at the maximum point of its swing? So that spot right there. What's the acceleration when it's right here? What is the velocity at that spot? What's the potential energy? What's the kinetic energy? And then all the places in between. So hopefully you'll be able to see that there are going to be some similarities. For the mass bouncing on a spring, when the mass was at its maximum compression or maximum stretch, it stops and changes direction. Well, the pendulum does the same thing. So right here, here, and here, and here, at the very peak, it's actually stopping and turning around and going the other way. Those are going to be easy spots. That's the zero velocity spot. If it's zero velocity, that also means it's going to be zero kinetic energy. Conversely, at the peak of its flight, at this high spot, that's going to be our maximum potential energy. And I think what you're going to find is when you copy down these two tables, when you're actually putting this into your notes, those tables are going to have a lot of similarities. So let's just flesh it out and see what we get.